Find the derivative of f of t equals the square root of 2t to the fourth plus 3t squared plus 4 all over t squared. Then evaluate f prime of 1. F of t here is the square root of an entire expression, 2t to the fourth plus 3t squared plus 4 all over t squared. Since I have a root, the first thing I need to do is rewrite this as a fractional exponent, and it's the entire quantity, 2t to the fourth plus 3t squared plus 4 all over t squared to the first power and second root or square root, so the entire thing's to the 1/2 power. Now the derivative will involve the power rule for the 1/2 power, and the inside right now is a quotient of two expressions of t and would make use of the quotient rule, but because we have a single term in the denominator, we have the option of writing each of the terms in the numerator over that single term in the denominator. And that might be advisable for the derivative because that'll remove the need for the quotient rule. So let's put each of the terms in the numerator over that common denominator of t squared, all of this to the 1/2 power. For the first one, we will be able to cancel out the t squared with two of the t's in the numerator, so it'll become t squared in the numerator. The second one, we'll be able to cancel out the t squareds completely. And then the third one does not have any t's that can cancel out. So f of t can now be written as 2t squared plus 3 plus, and then the third term here, I'm going to move the t to the numerator with the 4 as a negative exponent, t to the -2, so that the derivative of the inside of the 1/2 power will be much simpler to take. Instead of the quotient rule, we can just work it out term by term. Let's start the derivative now, f prime of t. Since we have a power outside of that expression, we bring down the power, leave the expression alone exactly as we see it, subtract 1 from the power. And because the expression is not just a t, but something bigger, we have to take the derivative of that as the chain rule. Derivative of 2t squared, 2 times 2 is 4, t to the first power. Derivative of 3 is a 0. 4 times -2 will be -8, and then subtract 1 from that power, which will be -3. And that completes our chain rule. Since we have a negative exponent happening here, it's happening when we take a 1/2 minus a 2/2, that'll be a -1/2. We're going to want to move that to the denominator. And we can then call it a positive exponent. So our f prime of t will now be, in the numerator, we're going to keep the 1 and all of this. So that'll be 4t minus 8 t to the -3. And in the denominator, we're going to have a 2 already down there, and we're going to have a 2t squared plus 3 plus 4t to the -2, and it will all be raised to the positive 1/2 power. Now in the numerator, I'm going to factor a 2 out because I have a 2 in the denominator that we'll be able to cancel with it. So I will have a 2 times a 2t minus 4 times t to the -3 all over 2. And then 1/2 power means square root first power. So the square root of 2t squared plus 3 plus 4t to the -2. The 2's can cancel. One more step, I'm going to write those negative exponents in the denominators of their respective terms. So I will have a 2t minus 4 over t cubed all over the square root of 2t squared plus 3 plus 4 over t squared. So there's our derivative f prime of t. We can now evaluate f prime of 1, which means to plug a 1 in for each of the t's. We will have 2 times 1 minus 4 over 1 cubed all over the square root of 2 times 1 squared plus 3 plus 4 over 1 squared. 2 times 1 is 2, minus 4 over 1 cubed, divided by the square root of 1 squared is 1 times 2 is 2, plus 3, plus 4 over 1 squared. 4 over 1 is just a 4, so we will have a 2 minus a 4 over the square root. 2 plus 3 is 5, plus 4. And 2 minus 4 is negative 2 over the square root of 5 plus 4, which is a 9. And that will give us a negative 2 over 3.